Alright, moving on to common sense and scientific inquiry. Dewey had a whole chapter about this earlier, chapter 4, I believe. So this just some kind of brings back some main points about this. Dewey reminds us of some important aspects of the relationship between common sense and scientific inquiry. So he writes, "The discussion up to this point has proceeded in general terms which recognize no distinction between common sense and scientific inquiry." So this chapter we haven't really been distinguishing between scientific and common sense inquiry, this chapter on the pattern of inquiry. We have now reached a point where the community of pattern in these two distinctive modes of inquiry should receive explicit attention. The communities, or maybe commonality or relationship. It was said in earlier chapters that the difference between them resides in their respective subject matters, not in their basic logical forms and relations. So common sense and scientific inquiry are about different things. They don't necessarily happen in different ways. They don't necessarily make use of different tools, conceptual tools, logical tools. It's just a matter of fact that, or of historical development, or whatever you want to say, that, of course, scientific inquiry does use some special techniques and tools. Scientists get funding that us regular folks don't have, so they do end up using some special things, but it's not required, and not a requirement. So that the difference in subject matters is due to the difference in the problems respectively involved. So they deal with different kinds of problems, in other words. And finally, that this difference sets up a difference in the ends or objective consequences they are concerned to achieve. And Dewey will explain more about these important differences. Right? So not necessarily a difference in logic, but a difference in subject matter, problems, ends, or consequences you're attempting to make manifest. Because common sense problems and inquiries have to do with the interactions into which living creatures enter in connection with environing conditions in order to establish objects of use and enjoyment, the symbols employed are those which have been determined in the habitual culture of a group. So once again, the common sense problems and inquiries are about our interactions with our kind of immediate environment, in making it useful to us, in objects of enjoyment, finding things that are that give us pleasure and that are useful to us. Right, so kind of all those daily life things are the problems of common sense. And let's see, and of course, you have to be a little bit careful here. Enjoyment doesn't necessarily mean entertainment or something like that, but you can enjoy a nice meal, you can enjoy the work that you do, you can enjoy your conversations with other people and things like that. All right. Interactions into which living creatures enter in connection with their environment. So the symbols that we use in those types of inquiries are the conventional symbols of our group. So language, right? Our standard language, for example, is the big one. They form a system, but the system is practical rather than intellectual. So the system of symbols that we use when engaging in inquiry, solving practical problems, the system is practical rather than intellectual, and we'll get a little bit of a hint as to what this difference means, really, but it is constituted, these symbols are constituted by the traditions, occupations, techniques, interests, and established institutions of the group. So our kind of symbolic language for dealing with these problems is determined by all these different things. Our traditions, the different kinds of occupations that we have, and so on. established institutions, so it could be religious institutions, economic institutions, educational institutions, anything like that. The meanings that compose it are carried in the common everyday language of communication between members of the group. Right, so the common everyday language. So there's no special language for solving common sense problems. The meaning involved in this common language system, the meanings involved in this common language system determine what individuals of the group may and may not do in relation to physical objects and in relation to one another. They regulate what can be used and enjoyed and how use and enjoyment shall occur. So we have rules or conventions maybe about how to use things, what we can do with things, what we can do with other people. So we can't just do anything. Sometimes this gets codified into law. Sometimes it's just a kind of general ethical sensibility. We're approved of and disapproved of by people in our society for how we treat things, what we do with things, how we use things, and all of that. So that's about the meanings involved in common sense inquiry and the common language system that is used in common sense inquiry. Think about maybe rules of etiquette is one example. If you look at different societies, things are complicated nowadays with kind of this advanced information society, globalized societies, and all of that. It gets very complicated and confusing. You can think about earlier examples of societies which had more clear-cut rules maybe about how you should treat animals that you kill for food, and who you can marry and not marry, and what you can eat and not eat and stuff. And some of those things still exist today, right? Think about all the rules, for example, in the Bible and similar texts. Anyway, so common sense inquiry. Because the symbol meaning systems involved are connected directly with cultural life activities and are related to each other in virtue of this connection, the specific meanings which are present have reference to the specific and limited environing conditions under which the group lives. So these meaning systems that we share as part of members of a community are directly about the environmental conditions we live in, or the context in which we live. They're not general. Sometimes we kind of universalize our own culture, our own community's habits and customs, but they directly have come out of our particular living situation and are really about that and can't really be generalized beyond our particular living circumstances. And this is, an example of why, or the reason why, cultures can be different in different environments. So desert cultures are different than rainforest cultures, for example. There's different rules about how to do things. Water is a much more important consideration for a desert culture. Many more rules probably about dealing with water than you would find maybe in a rainforest community, where you might have special rules about trees and animals that you would find in a rainforest situation. Only those things of the environment that are taken, according to custom and tradition, as having connection with and bearing upon this life enter into the meaning system. So we care about those things that affect our lives. We don't just in common sense, kind of everyday life, we don't just do inquiry into some subject matter for its own sake if it doesn't have any connection with our lives, right? It's just kind of ignored or beyond our field of vision. I don't know what more to say about that. There is no such thing as disinterested intellectual concern with either physical or social matters. For, until the rise of science, there were no problems of common sense that called for such inquiry. Right? We care about the seasons because that affects our food supply, right? That if you're a farming community, you really care about the seasons. This is something that science is a subject in science too. Scientists study climatic changes, weather patterns, and all of that. But in common sense inquiry, in common sense life, practical life, we care about that to the extent that it affects our lives, that it affects the kinds of food we can grow, that it affects the clothing that we're going to need or the fuel that we're going to need and all of that. So before the rise of science, we didn't have disinterested inquiry into, say, weather and patterns for their own sake. We cared about their effects on us. Disinterestedness existed practically in the demand that group interests and concerns be put above private needs and interests. So, the interests of the group are might seem disinterested from the perspective of one person. But there was no intellectual disinterestedness beyond the activities, interests, and concerns of the group. In other words, there was no science as such, although, as was earlier pointed out, there did exist information and techniques which were available for the purposes of scientific inquiry and out of which the latter subsequently grew. So, there were the roots of scientific inquiry in pre-scientific culture. So it's not totally unrelated, but it's a kind of abstraction in a certain way, or development, kind of independent development, relatively independent development of techniques and problems and information that already existed in pre-scientific cultures. In scientific inquiry, then, meanings are related to one another on the ground of their character as meanings, freed from direct reference to the concerns of a limited group. So much more abstract from actual living conditions. You're just talking about the relation of things to each other. Something like the relation of gravity and time. That's not tied, when a scientist talks about something like the relationship between gravity and time, you're not looking at the specific living conditions in a particular place. You're thinking at a very abstract level, freed from direct reference to the concerns of a limited group. Their intellectual abstractness is a product of this liberation, just as the concrete. So we've got these words abstract and concrete here put into relation. Their intellectual abstractness is a product of this liberation, just as the concrete is practically identified by directness of connection with environmental interactions. So abstract, you're separated, you're taking something away from or outside the realm of specific environmental interactions. Concrete, you're looking at the connections to specific environmental interactions and directness of connection to those interactions. Consequently, a new language, a new system of symbols related together on a new basis comes into existence. And in this new language, semantic coherence, as such, is the controlling consideration. To repeat what has already been said, connection with problems of use and enjoyment is the source of the dominant role of qualities, sensible and moral, and of ends in common sense. This last sentence actually kind of, I feel like, should belong to the next paragraph or something. So we can think of this maybe as the summarizing or concluding point here. So with scientific inquiry, you get new languages coming into existence. Specific scientific, technical languages, formal logic types of languages, symbols that are related to each other abstractly. Again, you think in a very abstract sense. What is time? What is gravity? How are these things related? And space, right? Time, space, for example. All right, and then He's going to talk about sensible qualities, moral qualities. How is that related to common sense? Right? So common connection with problems of use and enjoyment is the source of the dominant role of qualities such as sensible and moral qualities, and of ends, the goals that we use things for. These are related specifically to common sense. In science, since meanings are determined, and we'll come back to that. I think he goes into that now. Just this transition always confuses me. In science, since meanings are determined on the ground of their relation as meanings to one another, relations become the objects of inquiry, and qualities are relegated to a secondary status, playing a part only as far as they assist in institution of relations. So science is about relations. Relations in time or space, relations of mass, and other things of that nature. And qualities, and Dewey talks about primary, secondary, and tertiary qualities. These have a secondary status. They are not kind of direct objects of interest to science, but they can be useful still, because that's the world that human beings live in, is a world of qualities, and so it helps us to manipulate the world and understand the world when we think in terms of qualities rather than in abstract relations. And we'll go into more detail about that. So they, or I believe, where are we? Yeah, the qualities, I think he means by they are subordinate because they have an instrumental office instead of being themselves, as in pre-scientific common sense, the matters of final importance. So, in common sense, you want the fire to get the fire hot so you can cook, and that's important, right? That quality of fire is important, or the wetness of water is important for what it can do, or the coldness of something, or the goodness or badness of something. Maybe a better example, right? It's important that something is good or bad, that we determine it to be good or bad in daily life. For example, good for us or bad for us, or a good behavior to do or a bad behavior to do. Those things are of special importance to us, intrinsic importance to us in practical affairs. But in science, not so much. The enduring hold of common sense is testified to historically by the long time it took before it was seen that scientific objects are strictly relational. So it's really hard to, at least for, I don't know about scientists, but I think it's really hard for kind of regular people to relate to what's sometimes called the scientific worldview, the picture of the world painted by science, because it's lacking those qualities. And this is a problem, for example, with, I've been listening to a talk by B.F. Skinner recently, and I think that's a problem a lot of people have with Skinner's behaviorism, is that he puts human behavior all in terms of these abstract relations of, something comes before, something comes after, there's a behavior in the middle. So it's this kind of strict, not exactly strict, but there's a kind of, it's not exact, I wouldn't exactly call it cause-effect either. But, that's another example, these strict cause-effect relations that you have in certain kinds of physics, and these kind of antecedent-consequent relations that you have in kind of psychological behaviorism, where you're not looking at qualitative experience, you're just looking at behavior from the outside and relations between stimuli and responses, or situations and responses. And that seems very odd to people. It seems like you're somehow missing something, because you are missing something, right? You're taking something away or abstracting away from the everyday qualities of, color and sound and smell and good and bad and heavy and light and all of that we take for granted in daily life. So it produces this kind of odd picture of the world that I think a lot of regular people are not entirely comfortable with. So he says, first, tertiary qualities were eliminated. It was recognized that moral qualities are not agencies in determining the structure of nature. Right? So this is kind of this goodness, badness that I've occasionally been mentioning. That's a tertiary quality. Or happiness, sadness, these kind of feelings and judgments that we give to things that we say this is a very happy circumstance, this is tragic, this is good, this is evil. These are these kind of tertiary qualities we give to things. Then secondary qualities, the wet, dry, hot, cold, light, heavy, which were the explanatory principles of physical phenomena in Greek science, were ejected. So those are the secondary qualities. I relate this to kind of distance and contact perception. So, it wouldn't quite make sense necessarily for wet, dry, for some of these. But secondary qualities, we also think of things like color, sound, I believe. At least that's how I've learned it before. So I don't know if this is 100% accurate. I might be remembering things a little bit wrong, or maybe Dewey, it's not super important. But there's these different kinds of qualities. It doesn't matter which ones are primary, secondary, tertiary, and so on. But Greek science used these secondary qualities, but so-called primary qualities took their place, as with Newton and the Lockean formulation of Newtonian existential postulates. Don't worry about that. It was not until the threshold of our time was reached that scientific inquirers perceived that their own problems and methods required an interpretation of primary qualities in terms of relations, such as position, motion, and temporal span. So primary qualities, those were things, again, if I'm not misremembering this too badly, maybe should have looked it up beforehand, but primary qualities being things like shape and number, and I think I would have put heaviness here. Dewey mentioned it with secondary qualities. What else? Speed, motion of things, right? These are, the way I think about it, things that you can kind of feel with your body or your hands, whereas secondary qualities are related to, things you might smell or see or hear, a more kind of distance perception. And then tertiary qualities are where basically judgments come in, or in feelings. Okay, but it doesn't really matter. The point is, you're gradually getting rid of more and more of these kind of normal everyday qualities and thinking purely in terms of relations. And another good example here, the Skinner behaviorism example is a little bit ambiguous maybe, but something like the periodic table, right? So those are coming from, in a certain way, they're coming from everyday substances. Not all of them, of course. Some of those periodic elements are extremely rare and don't really occur naturally, but many of them are derived from everyday objects that have qualities to them that we would recognize. Some of them are gaseous. Some of them are solid. Some of them are liquid in kind of their normal form. Some of them are heavier. Some of them are lighter, right? But when you look at the periodic table, you're getting rid of those qualities. There's still a kind of hint of that in how it's organized, right? Because qualities still are important for us to understand the world. So the periodic table does, in a certain way, take account of those qualities in its organization, but that's really not necessary. Right? What's important is the kind of numerical relations among the elements and the numbers of protons and neutrons or whatever it is, the numbers of particles that you've got going on, and how many of this, how many of that, and yeah. So again, those qualities don't really matter, but they do aid us to think about elements. The foregoing is intended to indicate that different objectives of common sense and of scientific inquiry demand different subject matters, and that this difference in subject matters is not incompatible with the existence of a common pattern in both types. So, the pattern of inquiry that we have discussed in this chapter, moving through these different stages, is good for any kind of inquiry, but of course in science, you're looking at very often, much different subject matter than we deal with in everyday life. And you're dealing with it in a more abstract sense. There are, of course, secondary logical forms which reflect the distinction of properties involved in the change from qualitative and teleological subject matter to non-qualitative and non-teleological relations. And I'm not sure exactly what he means by secondary logical forms, maybe just the kind of specialized languages, mathematical formulae and things that are used in the sciences that are not so useful in everyday inquiry. But they occur and operate within the described community of pattern. So they occur within this same broad pattern that appears in both common sense and scientific inquiry. They are explicable and explicable only on the ground of the distinctive problems generated by scientific subject matter, right? So different sciences have different specialized languages and maybe kinds of logic that they use, but it all, at the end of the day, when you're doing an inquiry, it all fits within this common pattern. The independence of scientific objects from limited and fairly direct reference to the environment as a factor in activities of use and enjoyment is equivalent, as has already been intimated, to their abstract character. We've talked about that already, the abstractness of science. It's separate from practical affairs, from everyday use and enjoyment of objects with qualities that we latch onto, that we use and enjoy. It is also equivalent to their general character in the sense in which the generalizations of science are different from the generalizations with which common sense is familiar. The generality of all scientific subject matter as such means that it is freed from restriction to conditions which present themselves at particular times and places. Their reference is to any set of time and place conditions, right? So science is not about what happens in this particular location. It's kind of what happens just generally, right? So when you're looking at gravity, you're not really concerned with gravity, how strong a force of gravity is at this particular point where I'm sitting right now, or in this community or city or whatever. That could come up in a kind of practical inquiry for some reason. I'm not sure exactly how. But you're concerned with gravity as a general force. How does it operate on particular kinds of bodies? But it's going to be a kind of universal answer to that question. Gravity does this, or gravity is like this. Not just gravity in New York or London or Taiwan is like this. The reference is to any set of time and place conditions, a statement which is not to be confused with the doctrine that they have no reference to actual existential occasions. Reference to time-place of existence is necessarily involved, but it is reference to whatever set of existences fulfills the general relations laid down in and by the constitution of the scientific objects. So that just means that when you state a scientific principle, it's like given such and such conditions, this principle holds true, right? So there is a reference to actual things, right? If different principles would apply if you're talking about a vacuum versus if you're talking about an atmosphere. So something that is going to happen in Earth's atmosphere is maybe not going to happen when you're in vacuum. So there has to be a reference to the actual circumstances that this scientific principle would apply to, or this experiment, or this idea, or whatever. But it's of a different sort than practical inquiry, which comes out of, kind of in a grassroots way, comes out of our immediate circumstances and is applicable to those circumstances. And this is why different cultures have different kind of moralities in a kind of general sense, different conventions, different ways of looking at things sometimes. And science, of course, trying to go beyond that, find something that is universal. Okay, so last part of this chapter is the summary, and I'll deal with that in the next video. So, see you in the next one.